Hi, and welcome to this SOLIDWORKS tutorial for a dropout bowl mould. This tutorial will show you how to create a bowl model for a mould, check the model for undercuts, and then to create the dropout plaster mould of the bowl that would be used to slip cast a ceramic bowl. To begin, start a new part. The first thing I need to do is to create the bowl model that I want to mould. Sketching onto the front plane, use the centre line to draw a 50mm vertical line from the axis. Using the line tool, sketch back down over the top of the line by 49mm and horizontally by 32.5mm. Down by 1mm, level with the axis, then horizontally again by 5mm. This will be the foot ring of the bowl. Next, draw the top edge of the bowl by 75mm. Keeping the line sketch open, create an arc by hovering over the end point of the line so that the yellow icon appears. As you move away from the point, the line will turn into an arc. Just join up the sketch to close the profile. Revolve the sketch from the centre line to create the main body of the bowl. Sketching back onto the front plane, hover over the curved edge of the bowl until the edge highlights orange. Click onto it, it should highlight blue. When it does this, select Offset Entities. Reverse the direction of the offset to go inwards to the bowl and change the offset dimension to 5mm. OK the sketch and close it. I'm going to use this sketch as a guide to add a new plane and two sketches for a loft feature. Firstly, to add the new plane, I'm selecting the right plane as this will be my first reference. Then select Reference Geometry and Plane. When the Planes option box appears, you can see here that the right plane is selected for reference 1. My second reference is the end point of the guide sketch here. This brings the new plane perpendicular to the point. OK the plane. From here, I can use the new plane to create a new sketch. Viewing the new plane normal to, sketch a 9mm circle from the end point of the guide. Close this sketch and start another new sketch onto the top face of the revolve. Use the circle again and sketch a 30mm circle here. Then close this sketch. With the two sketch profiles done, select the Loft tool under Features. Clicking into the Profiles box, select the two circles. Viewing the feature preview from the side, the profiles are not lofting on a curve. Instead of using guide curves, I'm changing the start and end constraints. Select the arrow here to see the options, and under Start Constraint, select the Normal to Profile options in the drop-down menu. This makes the loft follow the direction the sketch is facing. Repeat the process for the end constraints. If I want to have more of a curve here, I can edit the constraints using arrows by clicking on and dragging it. It is quite sensitive, so you don't need to move it much to improve the curve, but you can also just type into the tangent length box to get a more precise feature. For this constraint, I have changed the tangent length to 1.5. Before I OK the feature, I need to untick the Merge Result box under Options. With the loft complete, I want to use this body to create a circular pattern around the bowl. Before I can do this, I need an axis for the feature to work. When anything is revolved, there will be a temporary axis. But to make this visible, I need to go to View on the top menu, Hide and Show, and select Temporary Axis. The bowl's axis will appear as a blue dashed line in the centre of the revolve. To create the circular pattern, click onto the drop-down arrow under Linear Pattern in Features and select Circular Pattern. When the box appears, the first piece of information the feature needs is the axis for the pattern. The second piece of information is what you want to pattern. For this model, I need to pattern a body, so check the Bodies box here and select the lofted body. When it's selected, a yellow wire preview of the feature should appear like this. Here I can see there are too many instances of the pattern. To change this, you can just type into the box here the number that you require. For this design, I want 15 copies. Viewing the model from the top, I ensure the lofted body's top faces are intersecting. When I'm happy with the preview, I can OK the feature. Right now, I have 16 separate bodies, but I want the pattern bodies to be merged to the bowl. To do this, use the Combine tool and change the operation type to Add. Select all the parts. They should all highlight blue like this and be listed here. Then OK the feature. The bowl is now one solid body. The design of this bowl is to be flower-like, so the next part of the design is the centre of the flower. Selecting the inner bottom face of the bowl, I'm using the Dome tool. I'm reversing the direction of the dome to make the face dome inwards. Keeping the dimensions at 10mm, but ticking the elliptical dome box to get a less circular profile. OK this feature. Using section view, I can see the inner profile of the bowl and the indent left by the dome feature. Fillet the inner edge of the foot ring by 1.5mm. Also, selecting one of the edges of the combine feature here. The intelligent fillet features options should appear like this. Hovering over the options, it will highlight the edges purple, showing the fillet it will create. For this feature, I want to fillet the connected to start face edges. This will fillet the edges of the combine that attach to the bowl like this. Once I'm happy, I OK the feature. With the bowl model design complete, I need to add a spur to the top of the bowl. This is needed to create the mould. The spur acts as a reservoir to feed the mould as it's casting. This is necessary because as the filled mould absorbs water, the volume of the slip is reduced, so the level of slip drops. Without a spur, this would expose the top edge of the casting, necessitating repeated topping up by the potter. The spur keeps the entire piece underwater throughout the casting process. Sketching onto the top face of the bowl, sketch a circle with 190mm diameter. Extrude this sketch by 10mm. Click onto the draft icon and change the draft direction to outward, keeping the dimension at 10 degrees. OK the feature, ensuring merge result is ticked. The bowl model is complete, but before I can create the mould, I need to check that there are no undercuts on my model. An undercut is a protruding or indented area of a model that prevents the removal of the model or casting from the mould. To test for undercuts, select Evaluate from the top tabs. Then select the Undercut Analysis tool. When the options open, I need to select the direction of pull. For this model, it is the flat bottom face of the bowl. This would be the direction the mould would come away from the model. The model will automatically highlight with different colours. If there are any red faces on the model, this indicates an undercut. The number of undercuts will show up here. The top face of the bowl has highlighted light blue. This would be the end point of the model, or the other side of a mould if it was in two parts. When you click the tick, the model will stay shaded with colour, with a key in the bottom corner. If you make any changes to the design, they will show in this key. Knowing that the model has no undercuts, I can create the mould. Sketching onto the top face of the bowl model, draw a 220mm circle. Extrude the sketch, viewing the model from the front. Reverse the direction of the extrusion and change the dimension to 80mm. There should be approximately the same thickness of mould around the bottom and sides of the bowl. This would ensure that the mould would cast evenly. Untick Merge Result and OK the feature. Now using the Combine tool, change the operation type to Subtract and select the extrusion as the main body. For the bodies to subtract, select the bowl model. You may need to select it from the Solid Bodies list. Once you've done this, OK the Combine. When the bowl model has been subtracted, the undercut analysis has now applied to the bowl mould. Here I can see all the inner parts of the mould are light blue, as the direction for removing a cast model from this mould would be upwards. I can now turn off the undercut analysis by going back to Evaluate and clicking on Undercut Analysis. Doing this will cause the key and colour shading to disappear from the model. To complete my mould, I'm adding the finishing touches. Selecting the bottom edge of the mould, click the chamfer icon. I'm adding a chamfer to the base of the mould for practical reasons. The chamfer makes it easier to pick the mould up from underneath. When the mould is full of clay casting slip, it is very difficult to pick up. It also minimises the risk of injuring fingers. For this chamfer, I'm changing the dimensions to 10mm, keeping the chamfer angle of 45 degrees. I'm adding small chamfers to the top edge of the mould too. This stops the mould chipping or breaking on the sharp edges. For these two edges, I'm adding a 2mm chamfer at 45 degrees. That is how you create a dropout mould. Casting of this mould would look something like this. This is the process I used before I created my own dropout bowl mould. It's good practice to design and test the mould model before creating the mould. It saves you both time and money in ceramics. Thank you for watching this SOLIDWORKS tutorial.